So now that we reached the final step of our implementation, I thought it would be wise to just stop for a bit and fill a little bit of the gaps that we left behind in terms of counting scan lines. Do you agree? I wasn't paying too much attention on skipping scan lines, counting scan lines, so in order to just fill that gap, I want to show right here in the screen a little quick analysis of the scan lines that we have. Especially because there are a couple of things that are happening between our scan lines, right? So remember, we are performing inside our VBlank. We are asking to execute a couple of subroutines, performing some tasks, and all these instructions that are happening inside the VBlank, they are using some clock cycles, right? They are using scan lines to perform those things. So we just have to be aware of how many scan lines we are using, checking if we are correctly looping everything with the correct number of scan lines. So that is why I want to do this quick analysis. Our code right now, this is what we have so far. If we start from the top of our frame, we start with our 3 lines of vsync, nothing new there. And then after the vsync, we are entering the vBlank area, right? And as we know by now, the vBlank area is responsible for displaying all the scan lines, but we are also performing some instructions. We are performing some subroutine calls and tasks inside the vBlank. That means that I need to count how many lines those instructions take, because instead of using the 37 scan lines, I'm going to have to use a little bit less, right? Because I am already wasting some scan lines with those subroutines. Okay, so I went ahead, I counted the instructions, the clock cycles, I counted how many lines they were using, and inside our vBlank area, we have 31 empty lines of vBlank plus 6 scan lines of vBlank subroutines and tasks. Right, so all those subroutines, those instructions, they are taking a total 6 scan lines. Therefore, I have a total of 31 plus 6, right, to reach my recommended 37 scan lines of vBlank. So that takes care of the vBlank section. After that, we enter our visible scan lines. And in the visible scan lines, we kind of divided our game into these 2 sections. We have the scoreboard at the top, and then later we have our main game area, right, with our jet, our bomber, the playfield, the river. So if we just analyze the scoreboard section, I also went there, counted instructions, and that gave us 10 lines of visible scoreboard. Remember, each digit has 5 rows of graphics, but each one of those lines are taking actually 2 scan lines to render. So we have 10 lines of visible scoreboard, the digit, plus 4 lines of padding that I just added for the sake of aesthetics. Correct? So the total lines of the scoreboard are actually 10 plus 4. So we have 14 lines just for the scoreboard, the digit and the padding on the bottom. So we already used 14 lines of our visible scan lines. That means that for the remaining part, the whole game with the play field, terrain, players, we have remaining 178 scan lines for all this visible game area that we have. So having this 178 remaining visible scan lines, if you look at our kernel that is displaying our scan lines, we are actually looping only 89 times. And the main reason that we are just looping 89 times is because we are using a 2-line kernel. So in our kernel pass, we are actually rendering 2 scan lines per pass, meaning that we loop 89 times to actually render all the 178 total lines. And that takes care of our visible scan lines. And we are almost there, right? The only thing that is left for us is to complete our 30 lines of overscan at the end of our frame. And that's it, right? That concludes one frame. After that, we jump to the next frame and start everything again. So 3 lines of vsync, 37 lines of vBlank, broken into 31 empty lines and 6 lines for the subroutines. And our 192 visible scan lines are broken into 14 lines for the scoreboard, 178 lines for the visible game area in our 2-line kernel, and our 30 lines of recommended overscan. And that's it for our scanline analysis. I thought it would be important for us to just stop for a moment and then go back, right? So I wanted to complete the code, and only after that I can go back, analyze the instructions that I'm using, doing a more careful analysis of the scan lines that I'm using, because this thing is important, right? We need to be aware and we need to be in control of how many lines we're using, how many clock cycles we're using. So I thought it would be important for us to stop, zoom in, analyze each one of these areas of our frame, and understand how many scan lines are needed into each one of the areas, how many lines are used for the scoreboard, how many lines are used for the visible game. And of course, I'm going to make this image available in the resources so you can download, analyze, and really understand what's going on into each one of these areas of our frame. So there we go. A quick analysis of the scan lines that we are using for our game.